right, welcome everybody. I think today we had a very exciting intro with a cat DJing us to the moon. Just to let you all know, this was made by a Russian YouTuber. We're gonna give him credit in the description. But I think we have a very exciting week behind us. I think today we have a lot to talk about. And maybe to say something first, right? It's very exciting to see the new excitement of IOTA in the market, right? Seeing a 200% increase in little less than a week is very exciting to see that. But I think I really want to remind everybody that we have a very big vision and very big mission ahead of us. And a lot of the really exciting developments and also really the fruits of our work at the IOTA Foundation and of the IOTA project itself are still ahead of us. And today I just wanted to start with a sort of recap, because I'm sure that there's many new people that have first heard about IOTA or that are kind of refreshing their memories since they first heard about IOTA in 2017 probably. So what is IOTA in 2021? I think that's a very important question to answer. And let's maybe start with the vision, right? The major vision of IOTA was the Internet of Things. And the major vision of IOTA still is the Internet of Things. We are still building the machine economy. And IOTA is the protocol that enables the machine economy, because what we do is two things, right? We do transactional settlement, i.e. machine-to-machine payments, which are feeless, which are highly scalable, and which are micropayments, right? And second, what we enable is data security, right? Value transfer of data and making the data immutable and making the data shareable. Now, all of that really evolves into this machine economy where machines start trading with each other. And they might be trading resources, they might be trading services, but more importantly, they're going to be trading lots and lots of data. And exactly that is what the IOTA protocol it was made for. And that is why we went on this quest to basically re-engineer the blockchain technology itself and come up with this new distributed ledger architecture, which is the Tangle. And over the last few years, we've really been focused on getting our DAG architecture right, making sure that it's scalable, that it's production ready, that we remove the biggest pain points and the biggest bottlenecks in terms of the adoption, and to basically present to the community and to the ecosystem a protocol and a technology stack that is really production ready, where we can really get it adopted, where we can really get it integrated into those machines and those IoT devices. And this year, we basically have a very exciting year ahead of us, where all of these different puzzle pieces are really coming together to build up this beautiful mosaic. And we have Chrysalis coming out in probably around a month, 4 to 6 weeks, which is the biggest upgrade in IOTA's history. And what we're going to do there is basically remove all of the non-standard technologies that we've utilized, all of the non-optimized algorithms, and really bring forward a new protocol that has been re-engineered from the ground up. And it's incredibly exciting because we're already getting so much feedback from our corporate partners and also from exchanges, custodians who are really interested to learn more about IOTA and about this new IOTA and what it also means to build on top of it, right? So we have Chrysalis coming out 4 to 6 weeks, complete new protocol, complete new tech stack, new wallet, new modules, all of that. But we're not stopping there, right? The vision of IOTA is the machine economy, and IOTA is the fundamental building block to enable the machine economy. But we want to go beyond that, and we really believe that IOTA is going to be one of these technologies of the future that enables trust, but that is also really building up entire new economies, right? And this machine economy is an economy, and it will see billions of dollars in value being transferred through it. And so once we have Chrysalis on the mainnet, the next big stage is obviously everything around and like further enhancing and further improving the use cases around IOTA, and also leveraging the IOTA Tangle to the full extent for some of these use cases. So basically what we have coming out is tokenization, where we have, for example, real assets, for example, real estate, but also IoT devices, sharing fleets, cars, but also digital assets like non-fungible tokens or digital art or data as well, right? All of that can be tokenized with IOTA and can then be traded. And the beauty of the tokenization system is that it's as secure as the native IOTA token. So we have that coming out. Then we also have smart contracts coming out, where unlike Ethereum, we're not taking this world computer approach, but we're really saying, hey, how can we actually build a scalable system where the scalability is parallelized, right? Where it's not just hundreds of devices securing one main chain and securing thousands of dApps, but where each dApp is sort of its own chain and has its own sort of validators and also has its own security, which is then leveraged by the IOTA Tangle. And our smart contracts are really exciting because they really also enable us to go towards this bridge building, where we can build bridges towards other cryptocurrencies, crypto assets, and also other blockchains. And then lastly, the biggest objective of the IOTA Foundation has always been to build the production-ready IOTA ledger, right? And the biggest criticism so far has always been the coordinator. And coordinator is basically this node in the network right now, which helps in the validation of the transactions because it was sort of seen as this bootstrap mechanism. And this year, or over the last 2 years, we've really been developing and further researching Corticide, right? How can we remove the coordinator and bring forward a new protocol that is feeless and that is scalable and that is fully decentralized? And this year we'll really see that being developed in code and being live on IOTA. And I think that will be incredibly exciting because now we are really fulfilling this mission and this purpose of the IOTA project. So yeah, really exciting year ahead of us. I think we also have a very exciting week behind us because there's a lot to talk about and a lot of information to disseminate, because some of these announcements that we push out can sometimes be hard to explain because sometimes people don't have the full context. So today we have a very exciting IOTA talk where we have one common theme, and the common theme is data. It's security, and it's the monetization of data. We have Daniel from the IOTA Foundation coming on the show in a few minutes after I spoke about ITO. And he'll talk with us about Stronghold, which is one of these fundamental building blocks that we've developed after the Trinity Moonpay incident / hack to really build a much more secure security stack. But as I already mentioned, right, the common theme for today is data. And data has always been one of those very important, I wouldn't call it use cases, but one of these very important aspects for us to consider with our technology, right? IOTA is not just about transactions. It is about data. And what we've always been telling to large companies when we did the workshops or meetings with them is data should be part of your balance sheet. Right? If you're a large company, you want to monetize your data. And that is exactly what these new distributed ledger technologies like IOTA are for, because they unlock your data. They make it shareable. They make it trustworthy, right? You want to trust the data that you purchase. You want to know the authenticity where it comes from. You want to be able to verify, right? And that is exactly what we at IOTA are here to do. And this week we had some very exciting news to share about that. First this week on Monday, we had this very exciting announcement that was pushed out, not by us, by the way, but it was pushed out by IOTA Grouper. And just to give you some kind of background on IOTA is like one of those Mittelstand Unternehmen, basically like mid-sized companies that are really world leading in their specific field. And IOTA specializes in mechatronics and in sensor technologies. And what's really incredible is that they were able to get an 11 million euro grant from the German Ministry of Transport and Digital Infrastructure to build out a new sort of test bed and also new technologies for autonomous vehicles. And what's very exciting here is that they work together with nearly a dozen large companies who are partners in this constellation. And what they're using IOTA for here is actually for the data security. So to quickly run through the use case with you, just so you better understand what this is about, right? What we're seeing right now is everybody's talking about autonomous vehicles being the future of mobility. And there's billions and billions of dollars being invested into it. And we have Google going for it. We have Mercedes, German automotives going for it. And everybody's sort of trying to train their vehicles for specific scenarios, right? So in California, we already have cars driving around in the city. But the big problem there is as soon as the vehicle sort of leaves this known terrain, it's prone to errors, right? And as such, we need to make sure that the vehicle itself gets data and can make decisions with that data. And even more important than that is that the data that it receives is trustworthy. Because think about an example where somebody shares fake data on purpose, right? A hacker or somebody who is trying to get somebody killed, right? All of that is possible with this automated future. And you can only fully automate our future and enable or empower those autonomous machines if you have trustworthy, verifiable data. And in this example with IOTA, what they are developing is basically a smart poles next to the road. And these poles have an identity and they're able to transmit data to the vehicle, and the vehicle can make decisions based on that. For example, if there's a construction on the Autobahn, on the highway, these poles will tell the vehicle exactly where to drive to, right? Or that it should slow down. Or if there is bad weather conditions, you would want to know how much worse your braking slope will get, right? All of this data is incredibly important to make autonomous decisions. And in this grant, which is worth 11 million euros, and this is definitely one of the largest that the German Ministry of Transportation gave out for such a project, they're going to set up a test bed in southern Germany to really try this out with trucks, right? And so this will be a real world project where IOTA is being utilized as a security component, so that every pole has an identity and is able to securely share this data with the vehicle. And the next stage of that will obviously be to actually build this out as a data marketplace as well, right? Vehicles selling data or buying data from the poles. And it's a beautiful showcase of permissionless innovation as well, right? Because the IOTA Foundation is not directly involved in this project, but we are really very excited about this project because they are utilizing IOTA as one of the core technologies in it. And the project will go for 3 or 4 years, I think. And we will release more information as we move along. It's very exciting to see this. And ITO is part of the IOTA ecosystem. And maybe we'll get them on the show in the near future. And with that said, let's talk about data security and let's talk about Stronghold. Daniel, how are you doing?
Hey guys. Hi. It's my birthday. Exactly to the day, actually to the minute, 1 year ago, I got a message from my friend Charlie who said, we've got a problem. Somebody's hacking the wallet.
Yeah.
And that was the beginning of the Moonpay incident that kind of kickstarted my time here at the foundation and ultimately led to us finding better ways to make our stack more secure. And what came out of that is actually a couple things. For one, we doubled down on the Rust programming language as a great way to have a solid memory safe foundation for code, but also in the way we've worked on designing things like the wallet, like Firefly, which is using a special type of communication that sends messages, which is really very similar to how the Tangle works and how a wallet communicates with the node. It's sending messages. And you're absolutely right. If we can't prove verifiably that somebody sent a message, well, then value transactions are just out the window. So we have to not only do that properly, but also securely. And that's where Stronghold comes in. As a matter of fact, we released a 6-minute video introducing the core concepts of Stronghold today. But the main feature, I would say, is that Stronghold isn't just a encrypted database. It's also a best practice approach for securely applying cryptography without ever revealing your secret keys. So that's kind of like you're saying, this foundation of the future tech that IOTA is bringing to the world right now.
No, it's very exciting. And by the way, everybody's telling you happy birthday. Happy birthday in the chat. No, but it's really funny that exactly a year ago, we had this rather extreme incident where Trinity suddenly we got like notifications on Discord. My funds were transferred, right? And so we went into this week-long investigation to figure out what's actually going on, because we got some misleading information from some sources. And so basically we went down this rabbit hole, and it became clear that somebody infiltrated the wallet and was able to steal the keys of the users.
Well,
yeah.
The attack was actually a supply chain attack, right? What that means is basically someone was able to change the code that we thought we were using inside of Trinity without us knowing about it. And that is a mistake that we've actually worked on resolving. For example, I'm sure there's a few nerds out there listening. One of the things that we're doing with Firefly and with Wallet RS and with Crypto RS and with Stronghold is we are actually pinning the source code to very specific Git commits so that it is impossible for code to be hijacked, because Git is also kind of like a code ledger, if you will. So if you know the name, for example, of a very specific commit in the code, you can always get that exact same code every time. And it's virtually impossible. I say virtually because nothing is impossible, but it's incredibly challenging to change that at build time. I mean, when we're building these actual apps. And after the fact, at runtime, it's absolutely infeasible.
No, so basically, one of the nice memes, sort of meme, that was made, I think it was made by Namen, right? Or somebody in the foundation. Is this one. And I think it kind of, if I hear the name Stronghold, I think about something protecting data secrets very well, right? And utilizing the hardware, but also utilizing the software environment within your computer to the maximum to really make sure that the secrets are actually secret and that a hacker cannot steal your source. So
there's one more thing, Dom, if I can interrupt you. I think what we've tried to do is actually enhance security through architecture. And what I mean by that is it is absolutely infeasible for an application to extract a seed once it's in the secure vault. And the only way a hacker is going to get your seed is if you give them either the password to your Stronghold or your mnemonic. And I think today people are they're much more concerned about giving someone their mnemonic or their password. So it's kind of like leveraging social awareness so that it's just hard to give somebody your seed. How? I mean,
totally. No, like it's a very interesting point, right? Because the good and the bad, like the curse of crypto, is that you have to keep your crypto safe. If you don't have a safe environment, if you don't keep your seeds safe, right, secure, right, hackers will try to steal them. We saw all of these crazy attacks, also social engineering attacks, where people are really trying to get your wallet files, right?
Right.
And Stronghold, and just to take a step back, right? I think our job as the IOTA Foundation and our job as a wallet developer of the IOTA wallet is really to make sure that we don't just take the best practices, but that we also lead it. Right. And I remember when I first heard about Stronghold, and I really thought that it is such an amazing initiative, because this is exactly what we need to be doing, right? After that incident, we needed to take a step back and completely rethink the architecture of the Trinity wallet, come up with a new name, right? Because it's kind of time to move on, and to really bring to the community, not just to IOTA, but also to the broader crypto community, a very safe module that they could be integrating into their wallets. So if I were to describe Stronghold, would you say that it's sort of like an agnostic environment or module to keep any type of data, any type of secret safe? So can it also be utilized by other crypto wallets?
It's a really good question. Basically, cryptocurrencies use cryptography, and it is totally feasible to use any type of cryptography within the confines of a stronghold, and you can store any type of data that you want. At a certain point, you might actually think about using something like a classical database if you're storing gigabytes of information in a single stronghold. But that has to do with the way that, we create a very robust snapshot, which is a file persistence. So you don't want to have massive snapshots lying around. You maybe want to have multiple. And I think, to answer your question, we've designed Stronghold not only to be agnostic from the perspective of how you want to use it, but we've also developed it as a kind of homogeneous architecture, which means that my Stronghold on my phone and my Stronghold on my laptop and my Stronghold on my USB armory are all going to be able to communicate with each other using Stronghold's internal peer-to-peer messaging system that is firewalled, revocable, permissioned, and allows us to do great things. Like once Firefly brings out its mobile wallet, there's going to be a way for the Strongholds to talk to each other, and you can use your phone as a second factor authentication. But it doesn't stop there. You can start splitting up records, and you can have half of a seed on your phone and half of a seed on the cloud, for example. So the homogeneous architecture really allows for a wide variety of use cases, and I think that's kind of where engineers get excited, right? Because the core is simple. Once you understand how Stronghold works, it's kind of obvious. But by having a secure runtime, which has got its own memory allocation, and a peer-to-peer network, and a storage, and a set of procedures, what we almost have is something coming close to an operating system.
Wow, wait, hold on, take a step back, because I think that sounds fucking amazing, and I think we need to clarify that a little bit. Basically, today, the way that this would work is I have my key phrase on my desktop, and I have one on my mobile. It's really a pain in the ass to share it between both of them, right? I remember having to download it on my phone, sending it via some kind of mechanism to my desktop computer, and then typing it all in again. Now you're basically saying with Stronghold, we are actually able to securely share the secrets between both devices because of the peering mechanism.
Right. I mean, just as an example, the moment you enter your mnemonic, or you create a new mnemonic for your master key, or you call it a seed, instead of storing it directly in a Stronghold, you could say, I want it to be split up to my USB Armory key and my mobile phone and my desktop. Also split it up into 3 pieces. So without these 3 devices, the seed cannot be used. I know this is not something for everybody. And of course, it's not going to be a requirement, but this is the kind of architecture that you can start envisioning, and you can actually empower your users to decide how they want to secure their data. You know, there's no reason to say you have to split it, but for some industries like banking or security software companies, having secure seed allocation distribution is the kind of thing that you don't want to trust it to email. You know, you don't want to be sending people signal messages with private keys in them. And at that point, you know, this ability for the devices to talk to each other in a secure way within the context of Stronghold will give you, as an engineer, as a software developer, and ultimately as a user, a much more broad sense of security instead of, you know, forcing people to send SMS or something.
Yeah. No, but this is really amazing. And I'm absolutely sure that Stronghold will also help with custodians, right? Because they're always thinking about new ways to keep their infrastructure safe. And Stronghold will be one of those key components there. So let's maybe talk about the current state of the project. We had this release on the 24th. And like maybe walk us a little bit through where we currently stand, because Stronghold will be utilized in the Firefly wallet, right?
Correct. So right now we are finishing off the final throws before we get to the beta stage. And I expect that we're going to be marking Stronghold as beta around the beginning of March. What that means, Dom, is that the major interfaces aren't going to change.
Yep.
The structure of the crates, the way that all of the logic is wired up is not going to change. And we are then ready for a full external audit. Right now, Stronghold is involved in the audit with Firefly. And that's a way for the external auditors to just make sure that all the pieces fit together, right?
Yeah.
And when it comes to Stronghold being marked as beta, what that means is we've worked through this first audit, and then we're going to have a second audit, a much more in-depth audit. And what that's going to cover is it's going to cover our runtime, which is this memory allocation system. It's going to cover our usage of cryptography. It's going to cover our snapshot storage system. It's going to cover our vault in-memory database. It's going to cover our internal and external methods of encryption. And most importantly, where we want to get this is we want to have our strongholds talking to each other before we mark beta. And so ultimately, all of the features that we've been working on are coming together. The very last PRs are in review and being finalized. And I'm currently building up a desktop application for verifying that the peer-to-peer communications work. And that is something that we're going to be releasing to the X teams as soon as it's done. And
nice.
As opposed to other software products, I think, you know, with the IOTA protocol, I think that the IOTA protocol is something that needs to develop over time. I mean, we've seen the maturation of the system just in the nature of our IOTA smart contract protocol, and also with streams, and then how streams is growing together with these other products. And it seems like there's a lot of room for growth. And I feel that Stronghold is the type of product that can be finished. And this is something that isn't always the case with software. I mean, you might want to add more features. You might want to change stuff. We don't want to do that. We want to get to a solid, stable Stronghold as soon as possible, not rushing it, but I don't anticipate there ever needing to be a Stronghold 2.0. There might need to be some dependencies that get updated, but we've designed this system to work correctly from the beginning. I might get some flack from that because some engineers think that's impossible, but I feel like it's a great thing to strive for in the context of security, because you don't want to constantly be redesigning your security models because this is a complicated piece of kit. We want to just do it right. Do you know what I mean?
Right. No, I fully agree with you. And I think something as instrumental as Stronghold, which keeps your most important secrets safe, we need to finalize that, and not just in a 1.0 read, but really something that's hardened and that's not going to be changed. It's sort of like the same narrative as Bitcoin in that regard, right? Because Bitcoin also has this narrative like, let's not change it, please. and here we have something similar. But yeah, no, Stronghold sounds absolutely amazing. So it will be part of the Firefly release. What can developers do right now? Or what can they do in the near future? Because I think Stronghold will be such an amazing piece of software that we can even talk with automotives about, like automotive companies, that they should integrate it into their vehicle to do an IOTA car wallet, right? That's like one of their use cases.
We've taken an approach where we have a target group inside of the foundation, which is the wallet team that we work with very closely.
Yeah.
And we want to make sure that we are fulfilling the needs of the wallet team without compromising our needs for security and still keeping the system usable and safe. So, excuse me. After the wallets project is, I'm going to say wrapped up, but I mean, from our perspective, where everything's working the way they want it to, then we're going to take the identity product into the fold, and that's going to be our next main consumer. And then there's going to be a lot of discussions with streams. And I think, like, to answer your question, how people can use it today, I would say give us just a week or two. Try it out in the Firefly wallet. And I mean, maybe I will even make you know what? It's my birthday. I feel like giving out a present. I will put a Stronghold snapshot. When we release the beta, I will attach a Stronghold snapshot file to the blog post. And if you can crack it, you will get the IOTAs that I put inside. So there will be, like, it's my birthday. I can do this kind of thing.
IOTA Talks challenges. I like it.
Yeah. I mean, if you can crack it, then I want to know, and you deserve the bounty, so to speak. And I'm willing to really say that from conviction that we've built a really solid system. And I mean, our estimation is that it takes about 3 times the heat death of the universe, the duration of time until then, to crack it. And thankfully, there is no quantum supremacy out there right now. Mm-hmm. But anyway, if that happens, I want to know. If you can crack a Stronghold snapshot with quantum tools, let me hear about it.
Then you definitely deserve the IOTAs. That's it on that address. Yeah. But speaking about value, right? So seeds, it totally makes sense to me, the way that Stronghold works. Here's like another overview for you guys. But another important aspect of what we are working on is identity, right? It is the data that you want to share with a website, good example, right? We have this autonomous future. You want to book a car to go from A to B, and you want to personalize your experience within the vehicle to get the right sound on, to get the right colors, to get the right show on the TV within the vehicle. All of that means that the car needs to get you data to personalize your experience, but you don't want to share it with them because then they're going to monetize it and steal it. So how can Stronghold play a role in this situation where we want to share, where I want to share my personal data with a third party?
I would like to point out that it's not so much the sharing, it's the taking back.
Yeah.
Right. And this is actually one of the hardest problems in asymmetric cryptography where you have a public key and a private key, and then you give somebody your public key, and then they can prove that the message came from you. And then there's all this kind of encryption stuff you can do. But once you give somebody a credential, there's no classical method of revoking it. And that's kind of what this sketch is about. This drawing here talks about the exchange between a travel agent and Alice. And Alice wants to make sure that at some point in the future, she can revoke the access that she gave the travel agent to her data. And what we are working on here is this idea of borrowing information from Alice. And then when Alice says you can't have the information anymore, it's just not available. It's ultimately similar to the way in which you might use a remote database, except this is a massive peer-to-peer data system where everyone can permit everyone else, if they choose, to use or know that they have data. I mean, that's the whole point about verifiable credentials. I have a passport. I am not going to hold it up to the camera here, but I can tell you that the HR department of the foundation has seen it, and you can trust that, right?
Okay.
I mean, and
so it's like attestations.
This is the kind of thing that you want to be able to give people, but at the same time, you don't want to be giving it to them forever. And that's like, if you think back to a second about the way in which a stronghold is architected, we've designed it so that you cannot get the actual data out. You can prove that you have the data. You would maybe know what that data is. You can have attestations in there, but it's not going to be feasible for the travel agent to print out a copy of your passport. He will only know that there's a reference ID or something like that that says, yes, Alice has a passport.
Right. No, that sounds really exciting. And I think Stronghold is really one of those key puzzle pieces for this decentralized future where we really empower people to own their own assets, to be in control of them, and to basically also be confident that the architecture, that the products that they use, especially the wallets, that they're not the single point of failure in their future, right? Because if a wallet gets hacked, your tokens could be gone. And so Stronghold is really empowering people and also machines to own their assets, tokens, value, but also really data. And I think that's really exciting.
The machine part is actually quite important, I think. When we started talking about the Stronghold project, one of the people I consulted with a lot was Yella, who is leading the identity project. And we've had some very in-depth conversations about the need for an entity to know that it exists.
Yeah.
Right? Like, I think, therefore I am, that whole rigmarole. But how does a car know that it exists? How does it know that it is what it thinks it is?
Right.
And for me, this is all about this idea of cascading identifiers. I mean, the DID project is all about identifying things and to whom and to what they belong and which hierarchy. And from my perspective, this is the kind of granularity that machines need. They need to know who they are first. And then once they know who they are and what their capabilities are, then they can communicate with other participants in their networks. And for me, that's the thing that just grinds my griddle about all of these smart home devices that leave ports open and insecure practices. And it's because nobody puts the time into thinking about, like, how do we secure all of this? And what we're doing with Stronghold is we are building in security as a principle at the base layer, and everything flows out from that.
Right. No, that's a very exciting discussion. I think this gets us perfectly into the next topic, which is like, how do you actually secure data from the source? And Stronghold helps you to keep it secure, to actually share it with third parties. But one of the more interesting principles of all of this is really garbage in and garbage out, right? Basically, once you input data into the distributed ledger, it becomes immutable. And then if you share it with others, how can they actually verify that it is valid data, right? That they can verify that it has not been tampered with, but they cannot verify that it's actually valid. A very simple example, right, is let's say that we have a weather station down in California where it's really sunny, but the weather station is suddenly telling you it's raining. So how do you actually verify that it's raining if you purchase that data? And I think that's a very interesting problem to think about, because all of this data will be utilized by large companies. They want to acquire all of these data sets to optimize the algorithms, to make the machine smarter, and to actually make them autonomous. And as such, companies need to be able to verify this data. And they also want to make sure that it's authentic in that regard. And so here's a very interesting article. I can recommend all of you to really read this. But this whole data problem and this whole potential of data doesn't just start with large companies, large enterprises. I think especially in our smart contracts environment, it's a very exciting topic, because what we basically have is we have this contained system, which is a blockchain, which is a distributed ledger. And the difficult part within this network is how do you actually get data from the outside, right? For example, getting current stock market information, pricing information, getting data from an IoT sensors, or getting data on the current, like doing API calls to external databases where the data is not contained and where the data is not verified within the blockchain, within the DLT network itself. Right. So this is a big challenge, because we have smart contracts that want to automate, that want to make decisions based on data. But we need to get this external data into the distributed ledger for those smart contracts to actually make decisions and to actually work properly. And that gets us to another very exciting announcement that we had this week. As all of you know, we are really marching forward to build out this beautiful mosaic where all of these different puzzle pieces are coming together. We just spoke about Stronghold, which Daniel has done an amazing job in leading the project. And now it's part of the wallet, but the use cases for Stronghold go much beyond just securing your seed, right? And the same is with oracles, where we are getting very close to releasing the first alpha version of our smart contracts. And as I already mentioned before, smart contracts are their own contained environment. We want to make it possible for those smart contracts to communicate with the outside world and to get data and to make decisions with that data. And also what I mentioned in the beginning, IOTA does two things really well. Value transfers, i.e. tokens, the IOTA token, micropayments. And the second one is data, right? We want to secure data and we want to make that data shareable. And we have one interesting module which sits next to Stronghold, which is called Streams. And Streams is basically secure and authenticated and also encrypted data streams. All right, so you can input the data into the Tangle. You know which IoT device has put it into, or has verified it. And as such, it becomes immutable. And now you can also start monetizing this data. And that brings us to IOTA oracles. Right? IOTA oracles will be one of those key puzzle pieces for the future, so that smart contracts within the IOTA ecosystem are actually empowered through data and can use verifiable and also immutable data to make their decisions. And this was the first release that we pushed out. And it's a very exciting demo that you guys can also try. And I can also recommend you to just watch this video to better understand what first-party oracles are. But for us, this is really just a start, because oracles, smart contracts, tokenization, and obviously all of these data use cases, and also these automation use cases, they're really just a start for us, right? We're bringing everything together, and we are making IOTA production ready, and we are increasing the amount of use cases that really leverage the IOTA tangle. And yeah, so Oracles is very exciting. Daniel, what do you think about Oracles, and how do you think it actually fits together with Stronghold?
Well, data is great, but if you can't verify that the picture you're looking at or the video you're watching isn't some kind of deep fake, then you're liable to feel lied to, or you might even be tricked. And I think that the way that the Stronghold hardware, the hardware side of Stronghold is developing, is that we are going to be looking into a future where physically unclonable functions and secure elements and very specific hardware fingerprints are used as a means to verifiably prove that a specific chip, for example, has been responsible for providing this type of data to the Oracle. And I really have to recommend watching that video. It's great. Like, they just did a great job explaining it. And my favorite part about it is that there's just so much you can do with an Oracle. Like, if you trust the source.
Exactly.
And so I think where we're going to see Stronghold interacting with Oracle is that we might be able to figure out a way to have a verified Oracle, right? If it's some third-party API that's pulling, information from wherever, it is maybe hard to trust. Right. But if it's coming from a device that has registered its signing key, the public key for its signatures, and can prove that it came from there, then you can start to go into this trust world. But I do want to remind everybody, like, we are hardliners. We trust, but we verify. So just because it's Stronghold doesn't mean it's perfect. You still have to verify everything, verify all the things all the time. Yeah. And my hope is that we're going to see a Oracle for software production, where oracles are used as a means to verify the software supply chain, because that is the global weakness. Like, that stuff can go down so easily. Recently, there was a hack, and basically what happens is, with some programming languages like Node.js, you can specify an internal package, and if just the way that system worked is, if someone named that package and published it at NPM, the Node.js system would pull that attack package instead of the one you thought it was. And like, the software supply chain is so integral. And we've talked a lot internally about where we want to take the hardware versions of Stronghold in the future. I really very, very firmly believe that the best is going to be an FPGA, for the simple reason that, as opposed to an ASIC or something completely on the die, what you have with an FPGA is you have the ability to actually verify that the code that's on there is the code that you think it is. Right. And this whole thing is, if you're able to hook an Oracle into your build pipeline, and the Oracle is able to prove verifiably that everything is the way that you think it should be, then you've automatically hardened your delivery system. And I really look forward to that.
No, you made some very good points, and I think trust but verify is key to our entire blockchain industry, because we already saw previously where some smart contracts were relying on Chainlink, and Chainlink was down, or they were being fed wrong data. And now the entire smart contract system, oftentimes these are billions of dollars of value that are relying on these systems. It's not just like a supply chain attack. It's sort of like a supply chain attack, right? Because your reliance on one component in the entire system architecture really can bring the entire house of cards down. And DeFi is being fueled by oracles. And I think the way that we see us at IOTA is we really want to be a player in this system by offering our first-party oracles to DeFi applications, to other distributed ledgers. And the way that we go into this space is with a complete new architecture, where we start from the source, right, from the edge. And we'll talk about the Dell announcement soon. But basically, to your point, right, we want to secure the hardware. We want to secure or make the entire software stack verifiably secure, right? So that you can trust that at each point in time, the data has not been tampered with and that it has been verified from the source. And I think that's really key. Yeah.
Word.
No, but it's very exciting. So IOTA oracles, right? Securing the data on the edge. And I think the way that oracles will progress as well is that, first of all, I think everybody kind of agrees we do not want everybody to be a data source. While it is an exciting idea that everybody can provide and sell their data, we oftentimes cannot rely on those sources. What we can rely on is actually building systems where those data sources use proven technology, proven hardware, and verifiable hardware and software to actually provide this data. So just a simple example, the way that I think this will also evolve into is that in the future, for example, a weather station will have an FPGA, as you said, integrated. It will have Stronghold, it will have IOTA oracles, and it will directly feed the data into a weather oracle that is selling this data to hedge funds, to financial markets, to energy markets, right? You are being a source for a data source for this oracle, and you're going to earn money by monetizing this data. But we need to make sure that the data itself has been proven secure.
Right.
Through these first-party oracles. And that's just one simple example of how we are thinking about this. Obviously, we are also thinking about connecting APIs, right? If you are a company, you want to offer certain data sets from your user base, for example, let's say your Airbnb, and you want to actually sell metrics of your hosts, right? You can actually do that by utilizing IOTA oracles and feeding that data directly to smart contracts so that those autonomous decisions can be made.
That's a really good point. I think, a lot of engineering teams out there absolutely have faith and trust in their own data sets. And for a company like Airbnb, like you just mentioned, it would totally make sense to trust their own data and, feed off of it, right?
No, that's a very important point, and that's why it's called first-party oracles, right? Those that are creating the data should also be the ones that are submitting it and are attesting to its validity. And what's very exciting about IOTA is because we have this IoT focus, I think we can really be leading these not just data marketplaces, but really these oracles by working together with the hardware companies and by working together with those large enterprises that are generating the data, like IOTA Grouper, right? We had this exciting announcement. They are doing sensor technology. They will be an exciting partner for IOTA oracles, and I'm very sure that we'll at least be doing some interesting projects as part of this initiative as well. But in addition to that, right, we already have something exciting going on, which is Project Algorium. So this week we pushed out a very exciting sort of status update where we, together with Dell Technologies and together with Intel as a new sort of partner in this whole constellation, have been pushing out the new update to Project Algorium. Now, what Algorium is all about is securing data from the edge and actually giving it a trust score, right? As the data is moving from the edge towards the cloud, right? We want to make sure that it is verifiable, that it is secure, and that it has not been tampered with. And Project Algorium is sort of like this industrial-grade oracle. And I'm very excited about this update because we also are working out with Intel as a sort of partner, and Intel is also really focused on making hardware, right? That's their bread and butter, but they also focus on making trusted execution environments and making these sort of hardware secure modules. And what I can really encourage everybody to do is to actually join the webinar that we're hosting on the 24th of February, together with our friends at Intel, Dell, and also Accenture, I think, is part of it. And I'm really excited about how we're pushing forward Project Algorium, because this is also something which we can utilize to really make industrial oracles a thing, and also connect the industrial enterprise world with the digital world, and actually feeding that data into smart contracts. And I think as we bring out smart contracts, the first alpha version, we'll see some very exciting applications being built with oracles and with Algorium. So make sure to,
I mean,
yeah.
The thing that makes me so excited about this project, especially when you think about the combination of oracles with smart contracts, is that, you know, we have to be clear. A smart contract is really just a bunch of code.
Yeah.
And there's conditions, there's inputs, there's outputs. And when you have like, you know, an outlier, when you're taking a bunch of samples of data and there's an outlier, that's a reason for concern. And if you can like automatically throw your oracle through your smart contract, and your smart contract knows what to do, and
right.
you can distribute that across a large network, what that means is, you know, seriously, sometimes 5 milliseconds is too much time. Yeah. And if you don't have to transit across the planet to some render farm or something to figure stuff out, if you can do that right at the edge, it's super exciting, because you can shut that down right then and there.
Yeah, no, totally. And I think only through IOTA and through these projects like Algorium, we can actually build these really resilient networks, right? And IoT has to be resilient. It has to be not relying on a single point of failure, which is the cloud, right? And also it's closed source technologies, and Algorium is open source as well. It's hosted under the Linux Foundation. So I think all of this it's really exciting for the future, not just for the future of IOTA, but I think also for the future of the Internet of Things, because we can only automate if we can trust the data. And with smart contracts are all about automation. And so oracles are really a key component there. And we're putting all of this together also with trustworthy data, but also with trustworthy hardware. So I'm very excited about the next steps that we're taking with together with Dell, and also with some other partners on oracles. One last point that I wanted to make is sort of this article, just to kind of make fun, have a little bit of fun, because basically it's going on about how IOTA oracles reminded everybody that we use the coordinator. And I think like, hello, right? One of our largest projects this year is actually about removing the coordinator. So while this article doesn't fully get the point of oracles, of IOTA oracles, which is to really show to the ecosystem that we're going towards building out this beautiful mosaic, I think what everybody should be reminded of is what we at the IOTA Foundation have been doing the last 2 years. Right? We pretty much started with nothing and built up this huge foundation, built up this huge project. Today we have 120, close to 125 people in the IOTA Foundation, and 70% of that is R&D. We are one of the leading distributed ledger research organizations, and over the last 2 years, we've really been down and really been focused on making sure that the IOTA Tangle is being well researched, that the future protocol, which is about removing the coordinator, is peer-reviewed, right? That is one of the most important things, because as Daniel said, trust but verify. And there's projects that make out exaggerated claims, and we've also made exaggerated claims in the past, and we've also learned from that. And obviously, sometimes it's excitement, it builds up, but what we need to make sure of is that those protocols, those software pieces like Stronghold, like the IOTA Tangle, that they're well researched, that they're open source, that they're being battle tested. And that is exactly what we at the IOTA Foundation have been doing the last 2 years. We've been really building up this whole new architecture and this whole new consensus algorithm for this new IOTA protocol. And this year we're really excited that everybody is actually able to join, right? Join this exciting journey that we've had over the last 2 years, building up this new network, which is Corticide, right? So I think everyone should just be reminded of that. And just this week, we just published another paper on committee selection. Committee selection is very exciting for distributed random number generators, but is also going to be very exciting for smart contracts, right? Because our smart contracts are about having these dynamic committees. So with that said, I want everybody to really understand what we've been focused on the last 2 years. And for one, we have some really exciting research. And this year we are really applying and also showcasing to the world all of the research that we've been doing over the last few years and making it possible for all of you to participate. So I think we have an incredibly exciting journey ahead of us. Daniel, any closing words, comments, statements, rants?
Well, I'm just glad 2020 is behind us and the quarter side is ahead of us, and I'm really excited about this stuff. I mean, looking back at my year here at the foundation, I've just been so charmed by the amazing people I have the opportunity to work with, a wonderful and supportive community on Reddit and everywhere else. And I really
don't
think
forget
that,
spec.
There's great people out there everywhere, and and I don't know. I just think that it's such a wonderful opportunity to work in the open source industry, and enhance the security industry and support the future of distributed ledger technologies. It's I'm happy to be here, and I love it.
No, absolutely. And it's amazing to have you on the team and to be part of going from what has been one of our biggest mistakes and one of our biggest hits in terms of public image, which was the Trinity hack, to where we are today, right? Where we are taking this new approach, and you've also helped in leading that. So it's very exciting to see where we stand today. And I'm absolutely thrilled to see where we go with Stronghold. I'll definitely be sharing a few secrets between my phones and securing them, splitting them. And I think that's very exciting. So thank you everybody for watching. Thank you, Daniel, for joining us.
Thanks for having me.
Make sure to start the Stronghold repo on GitHub. we need more stars there.
Yes, we do.
And with that said, have a good weekend, everybody, and thank you.
Ciao.
Bye-bye.